Today, I'm putting the old girl on a diet. I'm gonna show you how to drop 25 pounds in a single day and still eat anything you want. Normally, I use the Optima red top battery in my performance cars, but I've decided to go a different route with the Trans Am project. I want something smaller and lighter, so I've been doing a bunch of battery testing using my red-headed girlfriend here. I've settled on a motorcycle-sized lithium battery with an incredible 700 cold cranking amps. It has no problem starting the 358 cubic inch 10.8:1 compression small block. That might be too much to ask for on an 800 plus horsepower 427 LS. So I plan on running a dual battery setup in the Trans Am. So here's where the diet plan comes in. The Optima battery has 800 cold cranking amps and weighs about 40 pounds. The lithium battery has 700 cold cranking amps and weighs about 7. Running two of them puts me at 14 pounds. I'm not going to get into all the testing specifics, but I can say that I did exercise Amazon's return policy quite a bit. Some of the things I like about this battery is that it has a pretty good battery management system, allowing for charge voltages of 13.5 volts to 15.5 volts and up to 30 amps. The downside to lithium batteries is usually its temperature range. -4 degrees to 140 degrees Fahrenheit on the discharge cycle and only up to 115 degrees during charge cycles. That kind of screws up my plan of putting the batteries in the area that I cut out during Season 3, Episode 6. I used the driver's side area for a custom dry sump oil tank. And even though I haven't had any issues with the under hood placement during the Chevelle testing, I'm not confident that those temperatures are going to be low enough in the Trans Am, especially during track days. So plan B is to mount the batteries underneath the passenger side dash in a slide-in mount. Now, it's make some lightweight battery trays. For this project, I'm using 080 thick 5052 aluminum. I like to draw out my designs on projects like this. It makes it a lot easier to figure out my total dimensions, which will be 19.5 by 17.5. Using the template I made from my drawing, now it's mark my cut and bend lines on the aluminum. Next, it's center punch where my lightning ventilation holes need to be. These are 1 3/8 and 1 3/4 holes. A little bandsaw time to cut off my corner drop-off pieces. And don't forget to deburr the cut edges. I'm using the Rotex punch to make my holes. You could use a hole saw for this, but the punch is going to be a lot quicker and cleaner. Obviously, with my design, I plan on bending my sides and my top lips. If you don't have access to a box pan brake, you can easily just cut the sides separately. It only ends up being 4 more welds. I'm starting with a double 90-degree bend on the end that will serve as the handle. Then the deep side bend and repeat. Small 3/4 inch 90-degree bend, flip it, and deep 90-degree bend. The reason this works is because there's about a 1-inch drop behind the base of the die, allowing clearance for the 3/4 inch lip. This may sound stupid, but don't forget to remove the protective plastic film from the aluminum before welding. and clean and prep your weld joints. Warning: read and follow all labels and your owner's manuals. For welding, I'm using 1/16 5356 filler metal. I've got my Multimatic 220 AC/DC set for 80 amps and 100 on the frequency, which is lower than the factory setting of 120, giving me a little wider arc. Since I'm welding outside corners, I set the balance to 72, because the lower balance will help clean the oxide layer off the sides that are falling away from the tungsten. I'm metal finishing my weld beads because I made my slide-in mount fit tight to the box measurements. Let's see if they fit. Looks good to me. Now I gotta make some battery securing straps out of the same 080 5052 aluminum and some 1/4" 6061. I'm cutting 4 pieces of the 1/4" 6061 to 3/4 inches by 1.5 inches long. Then drilling the center with a number 7 bit for a 1/4 20 tap. For welding the 6061 to 5052, I'm checking the Hobart Weld app to pick the best filler for these 2 different alloys. It's just as simple as picking the 2 alloys from the different drop-down menus. So on alloy A, we're going to pick 5052. And alloy B, we're going to pick 6061. And then hit View Filler Metal. So here's the filler metals they recommend by applications. So if this was an under a hood application, I would think temperature might be my first concern. But since we are mounting the batteries inside the firewall, I'm going for higher strength, ductility, and toughness. So that looks like 5356 is going to score high. In strength I got a B, ductility A, and toughness A. I'm setting the Multimatic 220 AC/DC to 185 amps, bumping my balance back up to 75 and frequency to 120. I'm just welding the outside 2 ends. For my top strap, I just bent it to conform to the top of the battery, and then drilled 2 9/32 holes for my 1/4 inch bolts. For starter type lithium batteries, they don't have as much a reserve capacity as a standard battery does, which is why I'm installing this battery selector isolator switch, so I can disconnect one or both batteries from the system. That hasn't been an issue with the Chevelle testing, because there really isn't anything drawing on the battery when not in use, like say an alarm system or any other accessory that might stay semi-powered up. In that test, during over a week of non-use, the battery still measured 13.4 volts, which is over a 90% state of charge. And for the Trans Am, having the ability to disconnect a battery ensures that I have enough reserve starting capacity during longer dormant cycles. The last thing I need to do is drill a hole to secure the battery trays to the mount. Both trays will be mounted with 1 bolt. Next time on Real Garage, I'm tackling another one of my pet peeves: storage issues.